So what we're going to cover today is something called hyperbolas. So on the notes, your hyperbolas, I'm going to go through the left column first, and then I'm going to go through the right column on your notes. So I'm going to start with hyperbolas that are open on the x-axis. They're going left and right. Hyperbolas that go left and right start off as the equation with x squared over a squared, and then it's minus. The minus sign makes it a hyperbola because one of these has to be a negative. Y squared over b squared. Remember ellipses where this was x squared and this was plus, and then it equaled 1. If it's a minus sign, that's what makes it a hyperbola, the minus sign. Whatever variable is the positive variable, that means it's going to be opening either up or down or left or right. So think of it like this. If the x is positive, it's open left and right on the x-axis. And then I'm going to talk to you about the y variable in a little bit. So this is the equation. There's two equations for hyperbolas. This is the equation when the hyperbola is open left and right. The y is a negative and the x is a positive. So that's one way to remember. When the x is positive, it's on the x-axis, opening left and right. So the way that you graph these, if you look at the green thing, it says the asymptote line. So in the notes, the very top, you see something like this. This is called a positive asymptote line. This is the mirror image of the negative asymptote line. And the way hyperbolas work is there's a vertex somewhere, and this follows the asymptote line but never crosses it. So this goes like this forever, and this hyperbola follows it. Same with this. This is symmetrical. We have to find the vertex, which I'll show you. And this gets closer. It approaches this line, but never crosses the line. Obviously, if this x is if the slope is wider, it's going to be a much more narrower hyperbole. Hyperbole means it's two symmetrical quadratics. If it's a wider slope, that means they're going to be wider. The quadratics are going to be wider. So the very first step that you have to do is you have to find these blue lines right here. Whether it's a graph that opens up and down or opens left and right, the very first step you have to do is find the asymptote line. And see how it says y equals plus and minus b over a on the left column? Look at the equation. X squared over a squared minus y squared over b squared equals 1. If you square root these bottom numbers, this is going to be your a and this is going to be your b. And when your x is positive, you're going to have a y line of plus and minus b over ax. So let's do an example. Let's just take something super simple. X squared over 16 minus y squared over 4 equals 1. And the question is, graph this hyperbola. How do you know it's a hyperbola? Because there's a negative variable. There's a negative x squared or there's a negative y squared, and it equals 1. It has to equal 1. Okay, the first thing I'm going to do is, remember, this is a squared equals this number, which is 16. So technically, if I square root both sides, I have a equals 4. Or to bypass this, I can just square root this to get a equals 4. This is always a squared. This is always b squared. So I can think of it as b squared equals 4. What does b equal all by itself? Well, square root this to get 2. Or just square root this and bypass that middle step. All right, so I'm going to write my equation right here. X squared over 16 minus y squared over 2. And I know my A, which is always your first term here, is equal to 4. Your B is always equal to, I'm sorry, this isn't 4. Sorry, this isn't 2. That's 4. The square root of 4 is 2. Okay. First off, what is your asymptote line? If you look in the notes, whenever it's an X is positive, it's Y equals plus and minus B over A. Or Y equals plus and minus 1/2 X. So if you were back in math 1 and it said graph Y equals 1/2 X and Y equals negative 1/2 X. Here's your graph. And I would do this. To graph up 1 over 2 positively, I go up 1 over 2, up 1 over 2. Then I will continue this. And then, to graph, if this was a negative 1/2, I would go down 1 over 2, down 1 over 2. And you're going to see I'm going to have 2 symmetrical lines. Okay, these are called your asymptote lines. So your graphs do not have to be 100% accurate. You can't really make it 100% accurate unless you're using technology to graph it. But I'm just going to be asking you about a couple things. Number 1, your asymptote line. Number 2, your hyperbolas. What do they look like? Look at the very bottom where it says your vertices. Your vertice means your 2 vertexes. That's what vertices plural means. It means your vertex for both of the quadratics, which is two of those quadratics are called a hyperbola. Look at the vertex. It says the coordinate for your vertex is 0 plus and minus your A, 4. So I have 2 vertexes. I have 0, I'm sorry, not 0. It is plus and minus 4, comma 0. I was thinking of the y for a second. So I have 2 vertexes, 4 and 0. Let's just say is 1, 1, 2, 3, 4. And this is negative 4, comma 0. So negative 4, comma 0. I don't know. Let's just say it's right here. Okay. Now, the way I'm going to graph this is I'm going to, and this is your guesstimation for the graph. You are going to just kind of curve it as if it was following the line but would never cross it. Same with this, you curve it as it was following the line but would never cross this line right here. And same thing, you're just going to curve it and kind of make it follow that line but never cross it. And as it gets closer, it approaches that value but it never crosses it. Okay. This, so far, you've done 2 things. You found your vertices and you found your asymptote lines. The next thing is called it's called technically the foci line, but it sounds so weird because I've always called it foci, even though technically it's not the correct mathematical name, the foci. But whenever I say foci, it just sounds funny. Foci. I'm just going to call it foci, but technically the correct enunciation is the foci. It just sounds funny when you say foci, so I've always said foci. All right. Anyways, the foci are the 2 points. Remember when you had quadratics that were symmetrical to the left and to the right? Same thing. So wherever the foci is, you got to find those 2 points. And the way you find it is you take c squared. I forgot it. I'm going to rewrite. X squared over 16 minus y squared over, I believe it was 4. Right? It was 4. Yes. think this was 16. I don't remember what I just had. I don't know. Yeah, I believe this is 16. All right, anyways, so your A was 4 and your B was 2. Yep, that's what it was. Okay. I'm just trying to remember what I had here when I was erasing. Okay, so first off, look at foci. It equals 2c, where c squared equals a squared plus b squared. Okay, so I gotta find my c, multiply it by 2, and those are the coordinates for my foci. I'll show you in a second. First, I'm gonna plug this in. C squared equals a squared plus b squared. C squared equals 16 plus 4 is 20. And square root it, square root of 20, so you're going to get your C equal the square root of 20. Why is that important? Because the foci point, or the foci points are 2 times your C. So what is 2 times root 20? 2 root 20. That is your foci points. 2 times C. Now you have to plot the coordinates of 2 times root 20. So what I would do is I would just square root 20. It's going to give you, I don't know, 4.3 or 4.4, something like that, and multiply that by 2. So it's going to give you approximately, I'm going to draw these out. 2 times root 20, 2 times 4 point something is going to be 8 point something. So let's say it's right here. And it's a positive and a negative right here. These are the foci points, which is negative 2 root 20 comma 0. And this is the positive 2 root 20 comma 0. Okay, if I lost you on any of this, that's what you're watching the video for, is you can go back and you can rewind everything to make sure you get it. We're going to do a couple example questions in a second. But what I did is I found these, which are the asymptote lines. I found my vertices, which are my 2 vertexes, and my 2 vertexes was plus and minus my A, comma 0. And then I found my foci points, or your foci points. I did C, this is the weird part, you do C squared equals A squared plus B squared, and then multiply that number by 2, and then those are your foci points, foci points. Okay, now we are going to do the next example. Okay, pause the video and see if you can do this equation. X squared over 9 minus y squared over 25 equals 1. First off, find the asymptote line. Okay. You should have square rooted this to get A equals 3, square root of this to get B equals 5. Now, since this is an X line, it's going to be curved left and right. And what you're going to do is you're going to graph your asymptote lines to start off. Now, my asymptote line is y equals plus and minus b over a x. So starting at the origin, because your center is 0, 0, so it would be right here. If this was x minus something squared and y minus something, you would move this left and right or up and down. But for today, it's just going to be centered at 0, 0. So I'm going to go positive 1, 2, 3, 4, 5 over 3. And I'm going to go a negative 1, 2, 3, 4, 5 over 1, 2, 3. Okay, so you can tell that your two quadratics or your hyperbola together is going to be a little wider. Okay, now I'm going to find my vertice, meaning where do I start on my quadratic? And look at the vertice. It's plus and minus 3 comma 0. So I'm going to have 3 comma 0, negative 3 comma 0. So 3 comma 0, negative 3 comma 0. Okay, and then I'm going to curve this out. This is kind of just a rough guesstimation. It's wider, so it's going to be wider. All right. Okay. The reason why I break this up in the notes like this is because it looks like you have two linear lines, and then it looks like there's no distinguishing between one or the other with these and this, so it just kind of makes it look a little easier. Next thing is the foci or foci points. So this is the weird one where you'd say a squared equals, c squared equals a squared plus b squared. So you have c squared equals a squared, 3 squared is 9, plus b squared, which is 25. And you're going to have c squared equals 34, and then you square root both sides. So you have your c equals the square root of 34. Okay, and your foci is 2 times this, so you're going to have, your foci is 2 root 34 comma 0, and your other foci or foci point is negative 2 root 34 comma 0. The square root of 36 is 6, so 2 times 6 would be negative 12, 2 times 6 would be positive 12, but it's not. It's almost positive and negative 12, so you know it's going to be way out here somewhere and way over here somewhere. Your foci or foci points, your hyperbola giving you your vertice, and your asymptote lines that create the shape of the vertice. Okay? I'm going to, I think I'm going to skip the x squared minus y squared all over 1 equals 1 because I know that I don't want to make this video super long. And what I'm going to do is I'm going to go into the 2 example questions for the right-hand side of your notes, which is the y lines. The only difference for the y lines is everything's on the y-axis. And your asymptote line, instead of plus and minus b over a, it's plus and minus a over b. So I'm going to start off with, it's going to say graph y squared over, let's do the first one, 49 minus x squared over 32 equals 1. Okay, here's my graph. And your graphs can be this simple in the test, or just on the work. It doesn't have to be nice and perfectly looking graphs, obviously, because mine aren't, but I don't care. It doesn't matter to me. First off, I'm going to graph the asymptote line. First, I got to find my A. Your A is always your positive. Your B is always with the fraction that's negative. So square root 49, which is 7. Square root 32, which I don't know what it is, so I'm just going to leave it as square root 32. Square root 32 is almost 6. I don't know, it's probably 5.7, 5.8, something like that. Okay, now I'm going to write my graph. So let's say, I have y equals plus and minus a. Look at your asymptote line when you have a positive y. That means it's going to be facing up and facing down. That's what it means. So it's positive a over, let's just say square root of 32, just for the sake, is almost, so approximately 6. It's not, but it's close. Because when you're drawing your asymptote line, if I were to do this, I'm going to go up 1, 2, 3, 4, 5, 6, 7, then almost to the right 6. That means approximately 6. So up 4, 5, 6, 7, then almost 1, 2, 3, 4, 5, almost 6. Boom. There you go. And then it's going to be a negative down 7. 1, 2, 3, 4, 5, 6, 7. And then almost over to the right 6. 1, 2, 3, 4, 5. Almost over 6. Okay, these are called my asymptote lines. Now I'm going to figure out what my vertice is. My vertice is going to be on my y-axis. How do I know it's on my y-axis? Because my y is positive. Whatever variable is positive, that's the one that holds the action. So action meaning that's where everything is on. So the vertices is 0, comma, positive 7 and 0, comma, negative 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And it's gonna start to follow this. Something like this. It's gonna be wider. The wider your asymptote lines are, the wider your quadratic is. Okay. Last thing I'm going to do is I'm going to find my foci or foci points. So I'm going to say c squared equals a squared plus b squared. So c squared equals square root, or 7 squared is 49 plus square root of 32 squared is just the root goes away and it's 32. So you have c squared equals 49 plus 32 is a... Is this coming out to be nice and neat, really? 81. All right, that's good. Square root both sides. Hold on. 50, 60, 70, 9, 80. Yeah, 81. Perfect. Okay. So C equals 81. But that is not my foci points or foci. It is 2 times this. So 2 times 81 would be 162. So it'd be 162 is what your foci points is. This is your C. So it lies on your Y, so it would be 0, comma, positive 162, which would be way, way, way up here, and then 0, comma, negative 162, which would be way down here. Now, when you have a foci point that's that big, I'm not going to make you graph it. I'm just going to make you identify it. Okay, let's have you try the last one. I want you to square root. I want you to pause this video. Please pause this video and graph this. Y squared over 16 squared plus, oh, do this. I'm sorry, not plus. Identify, don't worry about graphing because this is going to be the numbers are going to be pretty big. Identify whether this opens up or down, left or right, what the asymptote line is, the foci coordinates, and the vertices are. So do everything except for graph it. Pause it and see if you can do it. Okay, so you had a chance to pause it. Let's see how you did. A is the square root of 16 squared, which is 16. B is the square root of 12 squared, which is just 12. So this is going to be open up and down. How do I know? Because my y is positive. The positive variable determines whether it opens up or down, or if the x is positive like we did in the beginning video, it opens left and right. Next, I've got to find my asymptote lines. Whenever it's y, it's a over b plus and minus. So I'm going to have y equals 16 over 12, which is going to be y equals positive and negative 4/3 x. I just reduced 16 and 12 both by 4. So this is your asymptote line. Let's see if you got the vertices correct. Vertices, it's on the y-axis. Your vertices and your vertexes, which are called vertices when they're plural. It's 0, comma, positive 16 and negative 16. Okay, and then the very last thing is your foci, which is the weirder, foci. So you're going to have a squared equals 16 squared plus 12 squared. I'm going to get my calculator out so I don't have to do this on a piece of paper. 16 squared plus 12 squared. And I'm going to get 400. I get a squared equals 400. Square root it, and I get, this isn't A, I'm sorry. This is C. C. So my foci point is 20, but it's not 20. It's 2 times this. Your foci points are 0, negative 40, because it's 2 times this if you look in the notes, and 0, positive 40.